guys, my name is Eliza, and today I'm going to talk to you a little bit about radio telemetry and its uses in conservation biology. But first, let's get started with the basics. One of the most commonly used technologies in wildlife monitoring is radio tracking or radio telemetry. The study animal is captured, usually by means of tranquilizer or anesthesia, and is fitted with a collar that transmits a signal. Each individual unit emits a very high frequency, or VHF, that is specific to that collar and so that animal. Using a directional antenna with an attached receiver, a researcher can find each individual animal by tuning the receiver to the animal's specific collar frequency. There are three methods by which a researcher can initially find a collared animal: homing, triangulation, or using fixed towers. First, the operator searches, by foot or vehicle, for a specific frequency by rotating the antenna. Once that frequency is detected, the operator begins to home in, or travel towards, the signal. The stronger the signal pulses, the closer the proximity to the animal. Homing in allows a researcher to find the animal's exact location. This direct approach can provide the opportunity to collect various types of data, but may disturb the animal. The next method is triangulation, which uses 3 or more points from around the signal's origin. The operator, or a software, calculates the intersection of the 3 points. This method is less precise and produces less data since visualization isn't always possible, but allows the animal to remain undisturbed. The final method is using fixed towers to receive signals. This method is most useful for studying a large group of animals or when the study animal is within a defined set of parameters. Radio telemetry has allowed researchers to collect data on various aspects of ecology and biology, including home ranges, movements, reproductive habits, social behaviors, predator-prey interactions, intra- and inter-species interactions, and individual animal conditions such as heart rate or temperature. This data can be used to develop species management plans, habitat protection and restoration, conservation laws, and regulate hunting and tourism thresholds. Let's explore a few of the ways radio telemetry has made an impact on conservation. The greater sage grouse are sagebrush-dwelling, heavy-bodied birds found in the mid to northwestern United States. Radio telemetry has exposed core habitat areas for grouse that support breeding and year-round nesting sites. Entities such as the U.S. Division of Wildlife, individual states' Fish and Wildlife Departments, the Nature Conservancy, and local landowners and sportsmen have used data collected by radio telemetry studies to protect important core habitat areas and the areas that link these sites in California, Nevada, Utah, Idaho, Montana, and Wyoming. The data has also provided insight on policies that affect habitat restoration and fire management planning in sage-grouse habitats. Wildlife Act is a non-profit conservation organization working within the Zululand region of South Africa. Conservationists here are dedicated to providing expertise on habitat and species management and protection while working with local communities to better harmonize life with important and endangered species. Researchers use radio telemetry to monitor animals such as black rhino, African wild dogs, vultures, cheetahs, lions, leopards, and elephants, and provide anti-poaching measures. By learning about animals' movement, population demographics, and social behaviors, researchers are able to influence conservation programs and protection laws, as well as track animals that wander from protected reserves. Daily tracking allows researchers to monitor animals for injury, illness, and entrapment in snares where intervention can occur before it's too late. Radio transmitters implanted in rhino horns sense movement and stress and can even detect when a horn is being removed, hopefully leading to poachers being caught in the act and apprehended. Like any scientific tool, it's best to analyze radio telemetry's strengths and weaknesses. This type of tracking can provide invaluable data on population dynamics, connectivity to habitat, travel routes, and overall movements. Simultaneous radio tracking studies can compare resource use and competition and space utilization. Monitoring cryptic and elusive animals, or those that live in rough habitats, is now possible because of radio telemetry. While it does require the user to be knowledgeable, radio collars and their equipment are relatively cheap compared to other technologies such as GPS tracking.
Created using Powtoon.